And what this allows is it allows us to come up with exact answers. The graphing method is a great way of visually seeing what the solutions are. And so going through and solving these quadratic equations visually. But similar to systems of equations, when we solve those, the downfall of the graphing method is unless the answers come out very nice for us as integers, it's really not very accurate. It's really hard to see if an answer comes out to be negative 1.173. It's really hard to get that answer using a graph. And so we want to have a way of finding exact answers. And typically in math, to find the exact answers, it's going to be more of an algebraic method. And that's exactly what the quadratic formula is. And so as you look at the quadratic formula, it still stems around our standard form. And so we want to get our equations into everything being on one side so that it's equal to 0. So we want all the x squareds combined, all the x's combined, all the numbers that are by themselves combined, and we want them all on one side. And then it'll be equal to 0. Once we have that, again, what we're trying to solve for is we're just trying to solve for x, trying to figure out what x is. To do that, the formula is we take the opposite of b. And so this number that's being multiplied by x, if it's a positive number, we're going to make it negative. If it's a negative number, we're going to make it positive. And so we're just taking the opposite of whatever it is, the negative of it. Then we're going to have that plus or minus. And so we've been working with this a little bit on evaluating it. We're going to take whatever this is plus the square root of this, and then we're going to take whatever this is minus the square root of this. And so we're going to end up with two different answers when we do that. Here, notice we're not taking the opposite anymore. We're just taking exactly what b is, and we're squaring it. Now, no matter what b is, when we square it, this is going to end up being a positive number. And so, for instance, if b is negative 3 squared is 9. If b is just 3 squared is 9. And so either way, you're going to end up with 9 here, whether b is 3 or negative 3. And then minus 4ac. Remember, we really got to keep track of the sign here. In some way, you need to use this subtraction as a negative. And so you can think of it as negative 4 times a times c, or you can think of it as minus and then whatever 4 times a times c equals. But you got to make sure you use that one time in the problem there. And then we're going to divide that all by 2a. Notice that the negative b is getting divided by 2a, and the square root is getting divided by 2a. So it's easiest to calculate this first, figure out what that equals, and then just divide it by whatever 2 times a is. And we'll show that here in an example. So as we go through the example here, the first step when we have this is to go through and solve so that everything is on one side. And so go through and manipulate here. To get rid of a negative 5, I'm going to add 5. And I need to do that to both sides. So now I have negative 3x squared plus x plus 5 equals 0. Once you have it equal to 0 there, now you got your form. Notice that this is my a right here. The b is the number that's being multiplied by x. If there aren't any x's on there, then your b is just 0. If there aren't any numbers that are all by themselves for whatever reason, then c is just 0. The only number that can't be 0 is the a. The reason the a can't be 0 is if the a is 0, then we don't have a quadratic equation. And if we don't have a quadratic equation, we can't use the quadratic formula. Let's write the formula down here. Again, it's negative b plus or minus the square root of b squared minus 4ac, and that is all over 2a. Now let's go ahead and let's plug that in there. And so let's start looking at it. Our b is just 1. Since it's positive 1, I'm going to write it down as negative 1 because it's the opposite of b. Plus or minus the square root of 1 squared minus 4 times a. Now a is negative 3 times c, which is 5. And that's all over 2 times our a, and again our a is negative 3. Now you got to do the math here. I would not try to put all this on the calculator by any means. What I would do on this is I would try to calculate inside the square root first. And I apologize for my writing here. It's a little sloppy. 1 squared is just 1. And then I have negative 4 times negative 3. Now, negative 4 times negative 3 is positive 12. And 12 times 5 is 60. And so I have a positive 60, so it's going to be plus 60. Notice when I did that, I used it as a negative 4. So plus negative, I thought of the minus being with the 4 as a negative. You could also kind of cover this up and just say, okay, 4 times negative 3, that's negative 12. Negative 12 times 5 is negative 60. So you're subtracting negative 60. Well, if you subtract negative 60, that's just like adding. And then 2 times negative 3, whoa, 2 times negative 3 is negative 6 there. So I'll clean this up right now. That's going to be negative 1 plus or minus the square root of 61 all over negative 6. Now remember, this turns into two problems here. So we have negative 1 plus the square root of 61 over negative 6, and we have negative 1 minus the square root of 61 over negative 6. Now what we're trying to figure out here is we're trying to figure out what x is, and so what we're seeing here is that x can be two different things here. And so x could be this, and x could be this. When we do this, because 61 is not a perfect square, we're going to get a real ugly answer. We're going to get an irrational answer here. And so when we write our answer, remember how to show that. We rounded it, because we're going to have to round it. We're going to want to put a squiggly equal sign. If we were told that we had to give an exact answer, because the 6 can't go into 1 nicely and it can't go into here nicely, we're not going to be able to do anything. And so this would end up being our exact answer right here if we had to give an exact answer. Most of the time on these, though, what we'll do is we'll give an approximation. And to show them that we're approximating, we'll give that squiggly equal sign there. If you do this, if you go through in the calculator, what I usually do is I'll hit negative 1 plus the square root of 61. And then I'll hit enter, and that'll give me some value. Whatever value I get, then I'll hit divided by negative 6. And when you do that, you're going to get negative 1.14. And when you go negative 1 minus square root of 61, again, I hit enter. Then I divide by negative 6, and I get 1.47. Now, if you graph this, what you would have found then when you graph this is that it crossed the x-axis near negative 1, but a little bit to the left of it on the graph. And it crossed the x-axis on the other side at almost 1.5, not quite 1.5 if you had a real accurate graph. So the graphing method is still great, and it's still great for an approximation, but these answers are exact, and you're not going to be able to come up with those exact answers through the graphing method. So this is our algebraic way of solving these quadratic equations. It works every single time, no matter how big of a quadratic equation is or how small it is, whether it has decimals, doesn't have decimals, anything will work there as you're going through here. The one thing you have to watch out for is the situation that we talked about earlier, and it's when this b squared minus 4ac is negative. You can't have the square root of a negative number. Because you can't have a square root of a negative number, if this would ever come out to be negative, what you would know is there are no solutions. Okay, and so if this comes out negative, the answer to the problem is no solutions. And that'll happen sometimes. Okay, so let's end it with our patented jokes here. And so I want you to, I'm not the best drawer here, so really this looks like a stick person, but what I want you to think of this stick person as is a skeleton. And I just want to know, why isn't the skeleton dancing? When the skeleton went to the dance, why didn't the skeleton dance? Because he had nobody to dance with. Nobody to dance with. What did the ocean say to the beach? So, you got the ocean, you got the beach. What did the ocean say to the beach? The ocean didn't say anything to the beach. It just waved. And guys, you can't see me, but I am waving to you and hoping that you can have some bacon for breakfast tomorrow. See you then.